Imagine a world where humans can soar through the skies, defying the gravitational pull of Earth, much like birds. This isn't just fantasy, it's the reality every time a plane takes off, transforming thousands of pounds of metal into a gracefully floating vessel. The science behind this magic is not only fascinating but also fundamental to modern travel. Every day, millions look up to see these metallic birds gliding effortlessly across the sky. To the unaided eye, it seems like a simple feat, yet it embodies complex physics and years of engineering innovations. The principle that allows these giant structures to lift off and cruise above the clouds is known as aerodynamics. Aerodynamics is the study of how gases interact with moving objects. When it comes to airplanes, this field of physics explains how air currents manipulate the plane's wings to generate lift. This lift is what overcomes the Earth's gravitational force, allowing the plane to ascend into the sky. The journey of flight begins with takeoff, an exciting moment where several forces converge to pull an aircraft into the air. The most crucial forces at play here are lift, thrust, drag, and gravity. Each plays a pivotal role in getting and keeping the aircraft airborne. Thrust is generated by the airplane's engines. It propels the plane forward on the runway and through the air. As the plane accelerates, air flows over and under the wings. The shape of the wings is designed specifically to create lower air pressure on top and higher pressure beneath, producing lift. This lift force must overcome the weight of the plane dictated by gravity for takeoff to occur. Drag is the aerodynamic resistance experienced by the airplane as it moves through the air. It acts opposite to the direction of the oncoming airflow, essentially pulling the plane back as it tries to move forward. Pilots and engineers must balance these forces precisely to achieve a smooth ascendancy and subsequent flight. Once airborne, maintaining altitude becomes the next challenge. This is continuously managed by adjusting the balance between lift and gravity. To remain at a constant altitude, lift must equal the gravitational pull. This delicate balance is what makes sustained flight possible. The pilot can control the lift by adjusting the flaps on the wings and changing the angle of attack, which is the angle between the oncoming air and the wing. Increased angle of attack elevates lift but also increases drag. Finding the optimal angle is crucial for efficient flight. Additionally, the speed of the aircraft plays a significant role. Faster speeds generate more lift. External factors such as air density and weather conditions also affect how well an airplane can maintain its altitude. For instance, thinner air at higher altitudes provides less lift, requiring adjustments in speed or angle of attack. Pilots must be adept at responding to these changing conditions to ensure a steady flight. To the observer on the ground, a plane high in the sky can sometimes appear to be hovering. This optical illusion is due to the relative motion and distances involved. When a plane is flying towards an observer with little lateral or vertical movement relative to the observer's line of sight, it can appear stationary. This illusion is more apparent with high-flying aircrafts or when viewed from a great distance. The plane is, in fact, moving, but the vast scale of the sky and the distance from the observer make its motion perceptible only over time. This explains why some planes, especially when observed from a great distance, seem to hang magically in the air. Understanding this phenomenon requires a grasp of perspective and relative motion. It's a wonderful example of how our senses can be deceived by environmental factors and the basic principles of physics. This illusion, while simple, helps underscore the complex interplay of forces that govern flight. Flight remains one of the most remarkable human achievements. By mastering the forces of lift, gravity, thrust, and drag, we have learned to traverse the skies and connect distant parts of our world. The principles of aerodynamics, though complex, can be understood fundamentally by observing the natural world and the behaviors of flying animals. While planes do not truly hover in the way helicopters do, the illusion of a stationary plane in the sky serves as a reminder of the intricate dance of forces at play. It is a testament to human ingenuity and the relentless pursuit of overcoming natural limits. As we continue to explore and understand these principles, the wonder of flight will remain a profound symbol of human capability and creativity.